So today we're going to cover section 3 of chapter 2. Today we're going to learn how to use postulates and diagrams. So the first thing we're going to do is take a look at all of these postulates. And a postulate is just something that's determined from a definition or a rule. Now most of these we've already seen before, but now they're officially presented as a postulate. So again, don't memorize the number. So when you take the quiz or the test, if I give you a scenario and I ask you which postulate is it, don't tell me it's 2.1. I'll mark it wrong. Okay, you need to either describe what the postulate states or tell me the name of it. So the first one is called the 2-point postulate, and this just states that through any 2 points, there is exactly one line. And this is what we learned back in section 1, how to name a line. You named it with 2 points. So a picture for this first one could look like this. I could draw a line, and on it are 2 points. So through any 2 points, points A and B here, there is exactly one line. That's the first postulate. Okay, the next one is called the line point postulate. And this one states that a line contains at least 2 points. Okay, so what that means is no less than 2. You need a minimum of 2 points to form a line. So you need at least 2. You can have more. You could have 3, 4, an infinite number. But you need at least 2 points to make a line. And this is called the line point postulate. The next one is called the line intersection postulate. And this one states if 2 lines intersect, then their intersection is exactly 1 point. So if I draw 2 lines and I show where they intersect, their intersection is going to be exactly 1 point. And that's the green. The next one is called the 3-point postulate. And this one states that through any 3 non-collinear points, there is exactly one plane. So this is how you name a plane, by putting the word plane and then list 3 non-collinear points. So again, if I draw my plane here, and then I add in some points. So here is my plane, usually represented by some type of quadrilateral, so I'll just draw a parallelogram. And in there, I am going to place 3 non-collinear points. And I can name these A, B, C. So that's what a picture could be like, representing the 3-point postulate. Next, we have the plane point postulate, and this one states that a plane contains at least 3 non-collinear points. So remember, the word at least means a minimum of 3, so it can be more. So it can be more than 3, but you need a minimum of 3 non-collinear points to form a plane. The next one is called the plane line postulate. And this one states if 2 points are in a plane, then the line that contains them is in that plane. So if I draw 2 points in a plane, so if I draw my plane first, and if I add in 2 points, then the line that contains those 2 points is also in the plane. So that's how a picture of that could look like. And then the last one, the plane intersection postulate. If 2 planes intersect, then their intersection is a line. Let me see if I can draw this three-dimensionally here. So then the intersection of these two planes would be this line. So if that red plane were going through the black one. When two planes intersect, their intersection is always a line. The next one is called perpendicular figures. And a line is perpendicular to a plane if and only if. Look at this if and only if. We've got a biconditional here. Remember IFF? So the line intersects the plane in a point and is perpendicular to every line in that plane that intersects it at that point. And the way that we can tell that this line T is perpendicular is because it's got the right angle marks here. So this is showing us that when it goes through that plane, it is perpendicular to all of those lines that it intersects at that point because of the right angle indicator. The symbol for perpendicular looks like an upside down T. So whenever you see this upside down T, this is the symbol for perpendicular. For my first picture here, if you notice, it starts out with, if you didn't remember the name, this is actually the line intersection postulate. So the name of this is line intersection postulate. But let's say you didn't remember the name and you translated it as you saw it. So here, if you think about it, you're having the word if, and then what's pictured here are two lines. So if two lines intersect, then, and notice what's highlighted after the word then is that red dot, that red point, then their intersection is exactly 1 point. So on the quiz, you can either restate what I just did in white, or you can give me the name. Do not give me the number. The next picture, this is actually an example, this postulate is the plane intersection postulate. Notice in red is the line. So the name of this is plane intersection postulate. And again, if you translate it, if two planes intersect, then their intersection is a line. So the next example says to use the diagram to write examples of the plane point postulate. So I'm going to have two parts here. I'm going to answer and give examples of the plane point postulate, and then I'm also going to give examples of the plane line postulate. Now, I don't want you to restate the postulate. I want you to tell me specific information about the picture. So here, if I'm going to do the plane point postulate first, Remember, the plane point postulate states that a plane contains at least 3 non-collinear points. So what I'm going to say specifically for the plane point based off of this diagram is I can say that plane P, because right here, contains at least 3 non-collinear points, which in this picture are A, B, and C. So I don't want you to just restate the postulate that a plane contains at least 3 non-collinear points. If I ask you to use the diagram, I want you to name 3 non-collinear points. Now, the reason why I picked plane P is because plane Q, I only see points A and B there, and they're on the same line. I didn't have a third point. Now, for the plane line postulate, the plane line postulate states if 2 points are in a plane, then the line that contains them is in that plane. So now I'm going to make a statement based on the diagram. So what I could state is that point A and point B lie in plane P. You could also say plane Q, but I'll say in plane P. So line N containing points A and B also lies in plane P. So if 2 points are in a plane, then the line containing those 2 points also lies in the plane. And specific to this diagram, I'm using the points A and B and plane P. Now, if you didn't want to name the line as line N, you could have also named it line AB. You could have done this as well. So either way, to name that line, that included the points A and B. This one wants to know which of the following statements cannot be assumed from the diagram. So we're going to go through each one. So it says points A, B, and F are collinear. So let's look where A, B, and F are. So A is here, B, F, and they are all on the same line. So yes, you can assume that this is a true statement. So this one is yes. The next one, E, B, and D are collinear. So E is over here. Let me use a different color here. So E is here, B is here, and D is here. There is no line connecting those 3 points. Yes, it looks like you could draw a line to connect them, but if there is not a line drawn in there for you, you cannot assume that they're collinear. So this one is no. You cannot assume that those 3 points are collinear. The next one, line AB is perpendicular to plane S. So let's locate line AB. AB is right here. And notice the little right angle mark where it's intersecting plane S. So yes, because of the right angle mark, I can tell that line AB is perpendicular. So this one would be yes. The next one, line CD, which is over here, it says, is it perpendicular to plane T? Well, this one's lacking the right angle mark. So without that right angle mark, I cannot tell that CD is perpendicular. So this one would be no. And then the last one on this slide, it says that line AF intersects BC at point B. So let's look for AF. It's right here. And then CD, or BC, sorry, BC. And it says that it intersects at point B, which it does. So this one is yes. Last example says to name a pair of supplementary angles and a pair of vertical angles in the diagram. Now, as far as the vertical, let me do these first because there's fewer vertical angles than there are supplementary. There's a ton of supplementary. The vertical angles, remember, they're formed when two lines intersect and their sides form opposite rays. So I have a vertical angle pair right here and right here, and then another one right here and here. So for the vertical angles, I'll do the blue ones first. So I have a pair of vertical angles, and again, the order doesn't matter here. So the vertical angles could be PWV and TWQ. Now you could have also named it in reverse, like for the PWV, you could have said VWP along with QWT, either way. And then we also have the red ones. Let me go ahead, these are the blue ones. And then we have the red pair. So again, we can use PWT along with VWQ, or in reverse, so TWP along with QWV. And these were the red vertical angles. So for the supplementary angles, let me get some other colors in here. Remember, supplementary angles are a pair of angles that add up to be 180 degrees. They're also, another name when you're trying to find it in a picture like this, would be a linear pair. So for example, if I draw my line here, I have a pair of supplementary angles with this one and this one together. So for my supplements, let me get my white here. So for the supplementary angles, I can name the purple ones. And again, you can do it in reverse, but I'm going to go ahead and do PWV along with angle VWQ. That's one pair. Now, if I were to draw my line this way, I could also have a pair of supplementary angles this way. So I got a whole bunch of different supplementary pairs depending on how I keep rotating around my picture here. So let me name those ones that I just did in green. So these were the purple ones. Let me go ahead and highlight this. So these were the purple ones. And now I'll do the green ones. And that could be angle TWP and angle PWV. Those are the ones I just did in green. Now let's say we did the other side of the purple. So the other side of the purple could be this angle with this angle. So again, it's sitting on a straight line. So we would have looked at the line, the straight angle there, and then they form supplements. So that pair could be PWT and TWQ. And that would have been the red. I did a red initially, well, red and highlight. Okay, then we could keep moving around. So this has a bunch. So then I could also draw it this way. I did the top. So let's say I do this in orange. So if I do the line this way, I did the green on top, but now I could do orange this way. So I could do TWQ and QWV. So there's a bunch here, and you could just keep going around. So on a test or a quiz for this, just give me one, even though there's multiple answers here. And again, backwards or forwards, but remember, you needed to have, these both had to have the same vertex. So notice all these had a W as the middle letter. All right, so that is it for the notes on section 2.3.